7.4 is all about inverse functions. So let's suppose that we just had an imaginary function. I'm just going to make a table of values, x and y. And when x is -4, y is 1. And when x is 3, y is 2. When x is 6, y is 3. And when x is 11, y is 4. Now, don't bother trying to figure out how I came up with this. I just kind of picked some points, and but this is definitely a function because each input has exactly one output. But we're going to find the inverse of this function. We're going to find the inverse of this function. Now, inverse function simply means that the x and y values are switched. That's it. The x and y values are switched. So in the inverse of f of x, the new x values are going to be the y values. So x is now 1, 2, 3, 4, and the y values are the old x values, which are -4, 3, 6, and 11. Inverse function just means that the x and y values are switched. So, just to be clear, this is our function. This is our inverse function. X and y values got switched. All right, so what if I give you an equation? That's great if I give you a table. What if I give you an equation? It's almost as easy. To find the inverse function, you switch the x and y, then solve for y again. You switch the x and y and solve for y again. That's if you're given an equation. Let's do an example of this. How do you find the inverse of a function? Something like this. If we have f of x equals -2/3 x plus 4. That is, that's our function f of x. We're going to find the inverse. Well, we're going to switch the x and y. Remember, f of x is just another name for y. So what we got here is x equals -2/3 y plus 4. So get y by itself. We're going to subtract 4 first. So we got x minus 4 equals -2/3 y. Then multiply by -2/3 on both sides, and you get -3/2 x plus 6 equals y. Equals y. So then, the inverse of f of x, we annotate the inverse as this. F of x, but f is to like the -1 power. That means the inverse of f of x is -2/3, -3/2 x plus 6. That is the inverse of f of x. Now let's try another one. What if I gave you f of x equals x squared? Well, again, we switch the x and y. So this would become x to a different color. Let's go with orange. X is y squared. So now we got to get y by itself. How do you unsquare something? You square root both sides. So now you got y equals the square root of x. But since I used the square root to solve, I can't forget plus or minus the square root of x. So again, using this new notation, this inverse notation, this is the inverse of f of x equals plus or minus root x. So here's f of x, there's the inverse of f of x. All right, so I'm going to give you one more. Let's see if you can do it by yourself. F of x, I'll tell you what, keep going f. Let's go with g of x. G of x is 1/2 x cubed minus 2. So go ahead and pause it for a minute and find the inverse of g of x. All right, so let's find the inverse here. Change the x and y, so you got x equals 1/2 y cubed minus 2. Add 2 to both sides. X plus 2 is 1/2 y cubed. Multiply by 2 on both sides. So you got 2x plus 4 equals y cubed. Now, how do you uncube something? You take the cube root of both sides. So we should get the inverse, the inverse of g of x. The inverse of g of x is, now do I need to put a plus or minus in front of the cube root? No, that's only for even indexed roots. So this is the cube root of 2x plus 4. There is the inverse of g of x. Let's go to the second part of this lesson. There's going to be 3 parts here today, guys. Let's talk about verifying. Verifying inverse functions. Verifying inverse functions. Now, to verify that f of x and g of x are inverses of each other. F of x and g of x are inverses of each other. IFF. If and only if. Now here we go. F of g of x equals x. And that's important, g of f of x equals x. Now, in the last part of this chapter, we talked about composite functions, f of g of x and g of f of x. We're going to go ahead and verify that f of x, let's say f of x is 4x minus 8, and g of x, let's go with blue, that's orange, oh my goodness. G of x is 1/4 x plus 2. Now, in order to verify, again, these two things must be true. It's not enough to just find the inverse of f of x and determine that and see that, oh yeah, look at that, it is. We have to do both f of g of x and g of f of x, and both of them should come out as x. All right, so let's do a quick example of that. F of g of x. In this case would be, well, we're going with f, right? And f is 4 times something minus 8. And we're going to plug in g of x in for x in the f function. So we plug in 1/4 x plus 2. So if we distribute 4 times 1/4 x is x plus 8 minus 8, which is x. That one checks out. Totally worked. But now we also got to do g of f of x. All right, now we're running with the g function here. So that's going to be 1/4 times something plus 2. Well, what's going in for x in this g function? We're putting in the f function, which is 4x minus 8. So distribute, we get x minus 2 plus 2 is indeed x. That one totally works. Again, you can't just take the f of x and find the inverse and see that, yep, look at that, it's the same thing as g of x. You have to do these two composite functions as they come out as x. Why? Well, here's the thing. I'm going to be honest. This just gives us an excuse to do more of these composite functions. But next year in pre-calculus, this is going to be a big deal. These, how to find, I got a Cabela's email. Awesome. Next year you'll do a lot of this. Okay. One last section. Let's talk about inverse functions. And there's the bell. Oh, bummer. That's probably the last thing that you heard was the bell and me saying, what a bummer, whatever. But, hey, on the quiz tonight on Edmodo, tell me what was the weird email that I got? From what store? Anyways, so where I was last at was inverse as relates to graphing. Inverse graphs. Now, I'm going to draw one of my patented gross graphs. Just go ahead and draw one with me. And we're going to put some tick marks on here. All right, and then let's plot some points. How about -3, 1? How about 1, 5? And -2, 2. So some graph like this. You know what? Let's go 5, 4 as well. We're just making up some graph like this. Right? So, and this is called f of x. So what are the coordinates of f of x? Let's make a quick table of f of x. The points that we've got here, we had -5, 4. We got -3, 1. We got -2, 2. And -1, 5. All right, so at the beginning of the lesson, we said that inverse means that x and y trade places. So if I wanted to graph the inverse of f of x, what would be the new values of x and y? The new values would be 4, 1, 2, 5 for x. That would be -5, -3, -2, -1 for y. So go ahead and plot those points on your graph. I'm at 4, -5, 1, -3, 2, -2, and 5, -1. Okay, so because my graph is not the best, this graph is actually looks something like that, the inverse of f of x. Now, the inverse of f of x, f of x gets reflected across the line y equals x to get the graph of the inverse of f of x. There's actually a line y is equal to x like this, and this is actually a mirror image of f of x. Oh, I'm sorry, this is the inverse of f of x, isn't it? My bad. So the inverse of f of x is reflected across the line y is equal to x. All right, remember, tell me what was the weird email from?